Alright, hello guys, we welcome to this particular tutorial again. Now, in the previous video, we were able to drive all those four different parameters on how to convert from polar to Cartesian and then from Cartesian to polar back again. And then these are the four equations we use in these transformations. Now, there is three examples on the board here that has to do with transforming from Cartesian or from rectangular form to their polar forms. Now, we were given 1, 2, 3 examples to transform them from this rectangular form to their polar form. Question number 1 is 3x minus y equals to 0. Number 2 is x squared minus y squared equals to 4. And 3 is x squared plus y squared minus ax. Everything in the, everything there is squared, then is equivalent to a squared into x squared plus y squared. So now, before we delve into solving these problems, there are two identities that I want us to remember or recall, so that while solving the problem we are not going to have an issue with it. So the first identity is cosine of square of theta plus sine square of theta, and then the cosine square of theta minus sine square of theta. So this particular identity is equals to 1, while this one is equivalent to cosine 2 theta. So in solving one or two of these problems, we're going to make use of these two identities. So anywhere that we have cos square theta minus sine square theta, we substitute it with cos 2 theta, and then for cos square theta plus sine square theta is equals to 1. So the sign here is what differentiates the two. So now let's start with our first problem there. Now, having we been reminded of these identities, then the next thing is let's delve into solving our question. Question number 1, 3x minus y is equals to 0, right? So 3x minus y equals to 0, then we now use the equations 3x, x is r cos theta, that is 3r cos of theta, is, and then minus r sine theta, which is y here, r sine theta is equals to 0. So here we can divide 2 by r, so that all the r we get rid of it. Then now we have 3 cos theta minus sine of theta is equals to 0. So we divide through everything by cos theta, so that we have a combined we can have one identity here that represents the ratio of sine theta to cos theta. Then we have 3 minus sine theta all over cos theta is tan theta. This is equals to 0. Or 3 is equals to tan theta, or you call it tan theta is equals to 3. Yeah, this is the polar form of 3x minus y is equals to 0. It's tan theta is equals to 3, or 3 is equals to tan theta. The arrangement or the order of the arrangement doesn't matter. So that is the answer for the first question there. Now we go for the second question, where we need to employ the use of these identities. The second question is x squared minus y squared is equals to 4. So definitely x is r cos theta, and then y is r sine theta, then 4 remains 4. But here this one is minus, and then all of these are squared. X squared, y squared. So here you now, when we square these quantities, we have r squared cosine square of theta minus r squared sine square of theta is equals to 4, right? So from here now, then we now factor out r square, and we have cos square of theta minus sine square of theta, close bracket, is equals to 4. So now this identity equals square theta minus sine square theta. You remember that this one is equals to cos 2 theta. So r square cos 2 theta is equals to 4. This is the polar form of x squared minus y squared is equals to 4. As simple as that. So for the third question, or the third problem we're having here, let's see how we're going to deal with that. So the question is kind of long. I don't want to rewrite it because I'm solving right below it right now. So the question is x squared plus y squared minus ax, all this squared is equals to a squared into x squared plus y squared. So r squared, like r cos theta, that is x here, x squared, I'm going to put a square bracket here, minus is plus, then r sine of theta, that is y, and y is also squared. Now minus a x is r cos theta, then I close this bracket, and then I square everything. It's equals to a here is a constant, into, this is r cos theta square, then plus r sine of theta, r sine theta square. Alright, so this is equivalent to r square cos square theta plus r square sine square theta minus ar cos theta, everything squared, is equivalent to a square into r square cos square theta plus r square sine square theta. So from here, you know that r square and r square is common to this particular side, and then here r square and r square is also common to the side. So what we're going to do is we are going to factor. So definitely this side is the same thing as r square into cos square theta plus sine square theta here, then minus ar cos theta, everything squared, is equals to a square r square. When we factor r square outside, then r is not there anymore, but it's cos square theta, then plus sine square theta, right? So now, as the problem is getting a bit simplified here, we'll now see that we are having the identity that equals to 1. We said, recall that cos square theta plus sine square theta is equals to 1. Recall, let me start by cosine. Recall that this identity is equals to 1. Therefore, here we are it's just like multiplying by 1. So we have r square minus ar cosine of theta, then squared is equals to a square r square. This one is 1, so you don't need it anymore. So at this point now, you take the square root on both sides, so that you are left with r square minus ar cos theta is equals to ar. So you divide through everything by r at this point, so that this one and this will cancel, this one and this will cancel. Then here we have only one r, so that r minus a cos theta is equals to a, or r is equals to a plus a cos theta, which can be simplified to r is equals to a into 1 plus cos theta. So this is the polar form of the longer equation that we are having over there. So that is all for this particular video. Thank you so much for watching. See you in next tutorials.